Okay, this time you will have geometric mean. We will be talking about on how to find the geometric mean or geometric means of a certain geometric sequence. Another lesson for Math 10. Okay, first is we are going to do this activity. Complete the following geometric sequences. Okay, let's try this. We have 2, 6, and we have 2 missing terms here and 162. First is determine what is the common ratio, and that is 3. How did we get 3? That is simply dividing 6 by 2, so that is 3. Therefore, our common ratio here is 3. So we multiply 2 by 3, so we have 6. Multiply 6 by 3, you can have 18. And 18 times 3, we will have 54. And 54 times 3, and that is 162. Therefore, the missing terms of this geometric sequence is 18 and 54. Okay, let's have second example. We have 96, blank, 24, 12, and 6. So what is the common ratio here? That is 1/2, since 6 divided by 12, and that is 1/2. So we will multiply 96 by 1/2, and that is 48. Therefore, the missing term is 48. Okay, how about number 3? We have 12, 48, and then we have 3 missing terms, and the last term is 12,288. So here, what is our common ratio? And that is 4, since 48 divided by 12, and that is 4. So we will multiply 48 by 4, and that is 192. Multiply it with 4, and that is 768. Times 4, and that is 3072. So therefore, our missing terms are 192, 768, and 3072. Okay. Now the question is, how do we call these terms we inserted? As you noticed, there are terms here that we inserted. Okay, how do we call these terms? Okay, so we have the terms inserted between any two non-consecutive terms of a geometric sequence is called as, that is, geometric mean or geometric means. Okay, so therefore, in our previous activity, those terms we inserted, or those terms that we inserted are known as geometric means. Okay, so the geometric mean, or represented by GM, of a number between any two positive numbers a and b is the square root of their product. So this is how to determine the geometric mean of any two non-consecutive terms of a geometric sequence. That is simply the square root of their product. Okay, so this one, okay, we have here square root of AB, that is, this is how to determine the positive geometric mean of certain two numbers, two non-consecutive numbers. Or if we are asked to determine the negative geometric mean, so we will have this negative square root of A times B. This is also for the geometric mean, the negative geometric mean of A and B. Okay, since if we're talking about square root, we can have two values, the positive and the negative values here. So we will be looking for the geometric mean of A and B, that is simply the square root of A times B. And if we are asked to determine the negative geometric mean of A and B, so that's the negative square root of A times B. How are we going to apply this? Okay, example, and have this one. Okay, so we'll have, okay, example number 1. Find the positive geometric mean of 4 and 16. Take note, we are going to look for the positive geometric mean between 4 and 16. Okay, so that is solution. We have GM, this is the geometric mean. Okay. Since we are talking about the positive geometric mean, so that is simply the square root of A times B. So A here represents the first given number and B represents the second given number. So our A here is 4 times 16. And 4 times 16, that is 64. So square root of 64, and that is 8. Okay, since we are talking about the positive geometric mean, so we will have the positive 8. So our geometric mean between 4 and 16 is equal to 8. Okay, so we have example number 2. Find the negative geometric mean of negative 60 and negative 15. Okay, so take note. We are going to find the negative geometric mean. Okay, so we have negative square root of A times B. Okay, it's negative here since we're talking about negative geometric mean. Okay, so we have negative square root of our A here, our first term is negative 60, times B, which is the second given term, and that is negative 15. Okay, multiplying these two values, we can have 900. Okay, so negative square root of 900, and that is negative 30. So therefore, the geometric mean of negative 60 and negative 15 is negative 30. Okay, so that's for the second example. Now, how about if more than one terms or there are more than one term are needed to be inserted between any non-consecutive terms, meaning you are going to insert two or more geometric means. What are we going to do? First is you need to solve for the common ratio. Next, after getting the common ratio, we are going to multiply that common ratio to the first term, then to the next term, to the third term, and so on until we can arrive to the given last term. Okay, example. Okay, this one. Insert two geometric means between 3 and 192. So take note, we are going to insert two geometric means. So first, we are going to determine that here our first term is 3. Next, our n term is 192. Okay, and n is 4. Why is it 4? Since we are going to insert two terms and we are given with another two terms. So a total of 4 terms in all. Okay, so that's why our n is 4. Now, using this n term of geometric sequence, this one, we are going to solve for the common ratio. Since common ratio there is not found. So, substituting, our n term is 192. Our first term is 3. R is unknown, and our n is 4. Okay, so simplifying, we have 4 minus 1, and that is 3. Okay, in order to eliminate this numerical coefficient of r, which is 3, we are going to divide both sides by 3. Okay, so we can have here cancelled out. So r here, exponent 3 will remain, and 192 divided by 3, and that is 64. Now, what is the cube root of 3? And that is 4. Or a number raised to the power of 3 to get 64, and that is 4. So our common ratio here is 4. What are we going to do next? Take note, our first term is 3. Okay, this one. Our first term is 3. Multiply it by 4, that is 12. Times 4, and that is 48. And then times 4, that is 192. So this is our first term, this one. And this is our fourth term, and that's 192. Therefore, how do we call this 12 and 48? Okay, so this one is our geometric means. Okay, so these are the two geometric means that we inserted from 3 up to 192. So 12 and 48 are our geometric means. Okay, another example. This one. Okay, insert 3 geometric means between 5 and 3,125. Take note, we are going to insert 3 geometric means. Okay, our first term is 5. Our n term is 3,125, and our n is 5. Why is it so? Why is it 5? Since we are going to insert 3 geometric means, 3 terms. We are going to insert 3, and then we are given with 2 terms. So a total of 5 terms in all. So that's why our n is 5. So applying the nth term of geometric sequence, this one, we will substitute the given data. Our nth term is 3,125, which is equal to, our first term is 5, r here is unknown, and here is 5. Okay, so that is why this one will be replaced with 5. Minus 1, that is 4. Okay, so 5 minus 1, and that is 4. Now, eliminate 5, which is the numerical coefficient of r. So to eliminate this 5, we are going to divide both sides by 5. So divide this by 5. This one also, divide this by 5. So cancelled out this one. So what will remain here is r exponent 4. And 3,125 divided by 5, and that is 625. Now, what is the fourth root of 625? And that is 5. Or a number raised to the power of 4 to get 625 is equal to 5. So therefore, our common ratio here is 5. Now, what is our geometric sequence then? So we have our first term is 5. Multiply it with 5, that is 25. Times 5, that's 125. Times 5, that's 625. And multiply this by 5, and that is 3,125. So take note, this is our first term, 5. And our end term is 3,125, this one. So these three terms, okay, we inserted. These 25, 125, and 625 are our geometric means. Okay, so therefore these are the three geometric means we inserted from 5 to 3,125. Okay, I hope you learned something from this. This is Teacher Con. Napahan.